Okay. Good day. Today we are going to discuss the ghost plane, rather the Helios Flight 522. This flight was on en route from Cyprus to Athens, and the passengers were aboard a Boeing 737. Um, we're going to discuss or correlate the happenings of the airplane or the aircraft to what we have studied from midterm to finals. The first one we will be discussing are the types of failure suffered by Helios Flight 522. So the first one we have is the latent failure. So we all know that latent failures have an elapsed time before they happen to an aircraft. So the latent failures that happened during the flight, yes, during the flight were that the maintenance engineers may have inadvertently left the pressurization switch in manual mode and failed to notify the flight crew. This oversight directly contributed to the loss of cabin pressure, ultimately leading to the tragic event. The people in charge for maintenance did not communicate with the pilots that they left um, the pressurization on manual. They did not um, notify them. Even the pilots missed it. So the active failure, when the pilots did not monitor the pressurization system, it resulted to a complete loss of cabin pressure and subsequent hypoxia. Okay, so moving on, events of error. In this case, it is a catastrophic event since it had many lives taken um, and resulted in many casualties. So the next we're going to discuss are the errors in aviation related to it. No, so the in total we have three errors, but we're only going to discuss two. No? So the first error is the pilot error. So these pilots failed to adequately monitor the pressurization system, leading to a complete loss of cabin pressure and subsequent hypoxia. They were likely distracted by a faulty cooling system and were unaware of the pressurization issue. Based on the documentary we have watched, the pilots failed to do their flight checks thoroughly, or they have outdated procedures. That's why they missed checking the pressurization until it's too late, where they have already suffered hypoxia. Next is the maintenance error, putting the pressurization to automatic and also not notifying the flight crew. Next will be the type of is employed in this accident. So the type of human error is the error of omission. So this was an error of omission because the pilots had the necessary training for flying the aircraft but did not follow the SOPs. The pilots should have turned around and had an emergency landing, or even better, did their pre-flight checks thoroughly so that they could have resolved the pressurization being in manual. So if we were to see so many blinking lights or warnings on a cockpit, we should have followed procedures and just turned around for everyone's safety, no? So moving on to the next presenter, we have Vince de los Santos.
So now let's talk about the classification of errors that happened. So is the flight crash of the Helios flight 522 intentional or rather unintentional? So the error that occurred in the aircraft is considered as an unintentional error. So why? So failures which occurred before and during the flight were mainly caused by human error rather than deliberate actions. So this means that yung failure such as failure to reset the pressurization system to auto, and the flight crew's misinterpretation of the warning signals were just mistakes by the flight crew as well as the maintenance crew. So yung failures na to were not caused by deliberate actions. So when we say deliberate actions, these are things people do on purpose with intention and awareness of their actions. So it means doing something knowingly with a clear decision, not by accident or mistake. So therefore, we can conclude that the accident was caused by an unintentional human error. So next slide. So now we have the elements of human factors. So here are the elements of human factors we have noticed in the documentary. So first, safety engineering. So safety engineering in Helios Flight 522 can be related to the critical importance of thorough maintenance checks, proper system configurations, and effective training programs. So, since the purpose of safety engineers is to identify and prevent potential hazards to ensure the safety and well-being of people, dito nag-fail yung safety engineering aspect for Flight Helios. So, since nag-fail to, so failures na nangyari is that the maintenance crew yun nga, did not reset the pressurization system to auto. Yung flight crew did not catch the error during pre-flight checks. And lastly, yung ayun, both crews were not adequately trained to respond correctly to the pressurization warning signals. So ayun, it is important to conduct improvements in these safety engineering practices that could have potentially prevented the disaster. Ayun. So next is cognitive science. So yun, the crew's inability to recognize and respond to the pressurization warning was a critical cognitive failure. So this means that they had an incorrect interpretation of the reason for the warning horn. So this indicated that the flight crew was not aware of the inadequate pressurization of the aircraft. Yung naging interpretation nila dito is that the warning horn was a takeoff configuration warning, but clearly it was not. So ayun, it says here that human factors like attention, memory, and situational awareness play significant roles in such scenarios. So clearly, the pilots lack this. This highlighted that there's a need for improved training and support systems for the pilots for better cognitive capabilities. And lastly, medical science. So here it focuses on the physiological effects of hypoxia on the passengers and crew. So the passengers and crew suffered from hypoxia due to the low levels of oxygen in the aircraft. So common effects are yun, confusion, unconsciousness, and then eventually death, which is what happened on Flight Helios. So by using medical science, we can understand the effects of hypoxia on the human body. So as we understand hypoxia more, we can develop protocols and equipment like supplemental oxygen systems to protect against such outcomes if they were to occur again. So next we have Joseph Fernandez for the Filthy 15.
Next, we dive into the Filthy 15, a series of critical factors that contributed to the tragic outcome of Helios Flight 22. First, we examine lack of communication. There was significant breakdown between the crew and the ground control. The pilots failed to report the cooling system problem, a precursor to the cabin depressurization. Meanwhile, air traffic control did not notice the aircraft circling for an extended period of time without any communication. The lack of communication likely played a crucial role in a tragic outcome. Next, we address complacency. Both maintenance personnel and flight crew exhibited a concerning level of complacency. The maintenance engineer did not follow up to ensure the pressurization switch was returned to auto, and the flight crew neglected to verify the switch position during the pre-flight check. Next, the flight crew also demonstrated a lack of knowledge regarding the consequence of pressurization system being in manual mode. They misinterpreted the warning signs of cabin depressurization, which further exacerbated the situation. Last is lack of awareness. Additionally, there was lack of awareness that the aircraft had previously experienced pressurization problem, and the maintenance engineer may have left the switch in manual mode. This highlights a significant oversight in the maintenance process, emphasizing the need for thorough and consistent procedure to ensure aircraft safety. Next slide, please. Teamwork was also lacking. The crew failed to effectively communicate and address the aircraft's pressurization issue. The captain and the first officer did not check or verify the status of the pressurization system, leading to their incapacitation from hypoxia. Furthermore, the airline's maintenance and training deficiencies contributed to a breakdown in teamwork and effective problem solving, ultimately resulting in the crash. Next is stress. As the situation escalated, stress level in the cockpit soared, multiple alarms sounded, and the crew struggled to understand the nature of the problem, adding to the chaos. Next, we have distraction. The distraction caused by the numerous alarms and warnings in the cockpit, further hindering the pilot's ability to recognize the loss of cabin pressure, compounding the crisis. Last, we have lack of operational integrity. Finally, we must consider the lack of operational integrity. Helios Flight 522 had previously experienced similar pressurization problems. If this issue had been reported and addressed beforehand, this tragic accident might have been avoided. Next, for SMS, we have Mr. Obera.
So now we're going to talk about the safety management system or the SMS of the flight Helios. So on safety policy, Helios Airways had a safety policy meant to outline the organization's commitment to safety. However, the incident exposed gaps in the enforcement and communication of these policies. There were organizational safety deficiencies within the operator's management structure and safety culture, as evidenced by diachronic findings and audits prior to the accident, including inadequate quality system, inadequate operational management control, inadequate quality and operations manual, cases of non-attendance by management personnel at quarterly management quality review meeting as required, organization management and associated operational supervision not properly matched to the scale and scope of operations, inadequate monitoring of pilot certificates and training, insufficient involvement of management pilots in managerial duties due to lack of time, incompletely updated training and duty records, lack of updating of some manuals, and in part not fully compliance with regulations, key management personnel at time performing the work of two positions, periods of vacant key management positions, and also inadequate remedial actions on audit findings, including level 1 findings, which could cause suspension of the AOC. Now, moving on to safety risk management. In the case of Flight 522, there were failures in risk management, including inadequate preparation for emergency decompression of air and insufficient hazard identification. So, at an aircraft altitude of 12,000 feet, the cabin pressure that corresponds to an altitude of 10,000 feet, about 5 minutes after takeoff, the cabin altitude warning horn sounded. The initial action by the flight crew was to disconnect the autopilot, to retard and then again advance the throttles, indicated that it interpreted the warning horn as a takeoff configuration warning. The incorrect interpretation of the reason for the warning horn indicated that the flight crew was not aware of the inadequate pressurization of the aircraft. So the flight crew possibly identified the reason for the master caution to be activated due to the inadequate cooling of the equipment that was indicated on the overhead panel and did not identify the second reason for its activation. Example is the passenger oxygen mask were deployed that was later also indicated on the overhead panel. The crew became preoccupied with the equipment cooling fan situation and did not detect the problem with the pressurization system. After the deployment of the oxygen mask in the cabin crew members would have expected initiation of a descent or at least leveling off the aircraft. It could not be determined what actions were taken by the cabin crew members after deployment of the oxygen mask in the cabin, nor whether any of the cabin crew members attempted to contact the flight crew or enter the flight deck after passenger oxygen masks were deployed. So now next is the safety assurance. The Helios Airways incident exposed weaknesses in regular safety checks and maintenance procedures. During the pre-flight procedure, before start and the after takeoff checklist completion, the flight crew did not recognize and correct the auto-incorrect position of the pressurization mode selector, manual position instead of automatic. The green light indication that the pressurization mode selector was in manual position should have been perceived by the flight crew during pre-flight takeoff and climb. And lastly is the safety promotion. The investigation highlighted deficiencies in crew training and emergency response preparedness. Number one is organizational safety related deficiencies existed within the Cyprus DCA from at least 1999 and continued to the time of the accident. So these deficiencies prevented the DCA from carrying out its safety oversight obligation within Cyprus as evidenced by findings in previous audits, including lack of resources and qualified personnel, and inability to adequately perform the safety oversight activities as required by the ICAO, over-reliance on the UKCAA, inadequate on-the-job training for Cypriot inspectors to assume the duties for the DCA, lack of DCA internal expertise to assess the effectiveness or the technical aspects of the UKCCA inspections and work performed, ineffectiveness of the DCA, inadequacy of the structure of the DCA to support safety oversight on the current and future operations under the present circumstances, no risk management process, and lack of effective implementation of the corrective action plans for previous audits. In conclusion, the investigation into Flight 522's crash found that lapses in these SMS components, especially in risk management, safety assurance, and promotion, contributed significantly to the tragedy. This led to the recommendations for improving SMS practices in aviation to prevent similar incidents in the future. So that concludes my report. And now we're moving on to CRM, which is going to be reported by Mr. Guzman.
So next, the crew resource management of Helios Airways, specifically the flight number 522. So first, the resources or the cooling system. The flight 522 took off at around 9 o'clock local time. 3 minutes into the flight, the captain reported a problem with the cooling system to ground control, which appeared minor but still the pilot continued to fly. Ayun po na yung napansin na ni pilot na umiilaw na yung sa cooling system niya. Pero tinuloy niya pa rin, which is yung nagkaroon siya dun ng poor decision making. Kahit wala sa MMEL or Master Minimum Equipment List yung sa cooling system na yun. So next is the perception. The captain's perception is no good because he thinks it is only a minor problem. Until the aircraft climbed into its cruising altitude of 30,000 feet, a warning horn sounded in the cockpit, indicating a loss of cabin pressure. So what is the perception? Perception, sa in other words, it is the perspective of the pilot. the process of assembling sensation into a usable mental representation of the world. Then next is the attention and information processing. Loss of attention and information processing because of cabin depressurization and hypoxia or oxygen starvation. Ayun po, yung nag-cause ng poor information processing and poor of attention yung oxygen starvation inside the cabin and the cockpit. Next po. Then next is the motor program. The motor program of the pilot to communicate to the ATC and the two fighter jets failed because of cabin depressurization and oxygen starvation. Ayun po ay ang mainly nagiging cause po ng motor program is yung oxygen starvation inside the cabin and the cockpit. Kaya hindi po nakapag-communicate ng maigi yung pilot natin. Then delayed effects of errors. For pilots, both pilots and extensive experience and should have been able to manage the situation. For maintenance, the maintenance records revealed recurring issues with the air conditioning and pressurization system. Yung sa pilots yung nagkaroon siya ng active error kasi ayun nga tinuloy niya pa rin kahit alam niya lang may something wrong sa aircraft. And then yung sa maintenance naman ay na-oversee ng maintenance na naka-on nga pala yung normal mode ng sa cooling system. Then lastly, the divided attention and forgetting. The pressurization switch has reportedly left in manual mode during pre-flight checks, contributing to the lack of cabin pressurization. Ayun. So next po,
Pearl model. Pearl model prompts the four important considerations for human factors programs, which are people, environment, actions, and resources. Flight Helios exemplified a scenario where peer model was not adequately prioritized, leading to catastrophic consequences. So let us begin with people. Crew. The flight crew, including the captain and first officer, was not fully aware of the pressurization system status, leading to their incapacitation. And maintenance personnel. Maintenance staff left the pressurization system in manual mode and did not communicate this effectively to the flight crew. This happened during maintenance check prior to the flight to system not reset to automatic mode. This oversight contributed to gradual loss of cabin pressure during this flight. This flight crew did not notice these incorrect settings, leading to their incapacitation due to hypoxia. So next is environment. Cockpit environment. The environment within the cockpit included confusing alarms and alerts which were not adequately interpreted by the crew, and operation procedures, airline procedures, and checklists failed to ensure that the pressurization system was not correctly set and monitored. This failure played a significant role in the accident, and procedures did not adequately emphasize the importance of verifying the pressurization system settings, and checklists did not include sufficient steps to detect correct and incorrect settings. Next is actions. Crew actions. The crew did not follow standard operating procedures to verify the pressurization system settings, leading to their incapacitation from hypoxia. And maintenance actions. The maintenance team set the pressurization to manual and did not return it to automatic, a crucial oversight. The crew maintenance personnel failed to collaborate and communicate the status, compromising its safe flight quality. It was identified that between 9 to 6 hours after takeoff, the aircraft was under autopilot, making its way to Athens. Then at 11:50, autopilot was disengaged. the pressurization system was left in manual mode without reporting it with other officials, leading to a gradual loss of pressure. And lastly is resources. Training. Insufficient training for both pilots and maintenance personnel on handling pressurization issues and emergency protocols and equipment. The pressurization warning systems was insufficient clear and there were no redundant system to alert the crew more effectively. And communication. Poor communication between the maintenance team and flight crew to detect the incorrect pressurization settings. Insufficient training for both pilot and maintenance personnel combined with unclear pressurization warning systems, lack of redundant alerts, compromised safety each individual was on that flight. Accordingly, poor communication between maintenance team and flight crew led to undetected incorrect pressurization settings. Next po is recommendation based on Pearl analysis. Next slide po. The recommendation based on Pearl analysis include enhancing training programs, improving maintenance protocols, upgrading warning systems, fostering better communications between maintenance teams and flight crews. These are certain steps that can help prevent disasters and improve flight quality. Next is Swiss cheese model reported by Mr. Samson.
So next, I will be reporting about the Swiss cheese model of the Helios Airway flight number 522. The Swiss cheese model illustrates how the Helios Airway flight 522 incident resulted from a series of aligned failures in maintenance, pre-flight checks, crew training, and emergency response, ultimately allowing the accident to occur. So for the first layer of the Swiss cheese model, we have the latent condition, maintenance set pressurization to manual. So during routine maintenance, the pressurization control was mistakenly left in manual mode, preventing the aircraft cabin from automatically pressurizing during ascent and compromising breathable air pressure at high altitudes. The next layer, the latent condition, inadequate pre-flight checks missed the incorrect setting. So during pre-flight checks, the flight crew failed to notice the pressurization system was set to manual mode, allowing the aircraft to take off with a potentially dangerous configuration. Next, active failure. The crew did not recognize and correct the pressurization issue. During the flight, the crew received cabin altitude warnings but failed to identify them as pressurization issues and did not switch the system back to automatic, leading to a critical failure in addressing the problem. Next slide. So for the next layer, active failure. Hypoxia impaired the crew's ability to respond to warning. So as the cabin altitude increased without proper pressurization, the crew suffered from hypoxia, which impaired their ability to respond effectively and take corrective action. The next, latent condition. Training did not sufficiently prepare the crew for this specific scenario. So during pre-flight checks, the flight crew failed to notice the pressurization system was set to manual mode, allowing the aircraft to take off with a potentially dangerous configuration. Next, the defense mechanism gap. So the ATC and the emergency response were unable to prevent the crash once the crew was incapacitated. So after losing communication with the flight, air traffic control and emergency responders, including fighter jets, were unable to effectively intervene, highlighting a critical gap in the defense mechanism designed to prevent such accidents. So that is all for our presentation of Flight Helios 522. Thank you.